Hi, everyone. Good morning. Every morning. It's just silence. Good morning. Excellent. That's much better. I wanted to reiterate one of the purposes of this event is so that nobody gets excluded. Everybody who wants to come and hear from our speakers and hang out with each other can. So if at any point in time you feel unsafe or unwelcome or something weird happens or somebody says something weird, please grab someone in a blue shirt that looks like this. If you can't find someone in a blue shirt, you can find someone at the front desk and they will help you. So our next speaker is a mobile dev from Berlin. He has worked on artsy.io. He's worked on SoundCloud. He's worked on artsy. He's for hire Robb Böhnke.
All right. Thanks for having me. And let's talk about animations. Let's not talk about animations. Let's instead talk about state. I do this all the time. If you think of your application, right, as a series of states that it can be in. You know, the user can be logged in, logged out, a text field can be selected, unselected, keyboard can be visible, not visible. That is hard to write and that's hard to maintain, but it's also hard to use, right? If you're a user, you need to find your way through this maze over there. And our responsibility as developers is to guide the user. And one good way to do this is using animations because they provide context, they can reinforce the navigational structure. Think of the UI navigation controller, for instance. When you push a view controller on top of the stack, it like lays over the existing views, and then when you do an interactive pop, you're effectively just reversing this. So animations are much more than just flourish. They're actually very natural, right? I didn't suddenly appear on stage. That would be crazy. I walked from over there. You all saw that. So you had an expectation that I would arrive here, and I did. So it's just like a very natural thing, right? You go from one place to the other. And one way to do this is core animation. And this is what I'm going to talk about mostly in this talk. I'm not going to talk too much about the UI kit helper methods that are much more high level. They are using core animation under the hood. But one of the benefits of using core animations in the example is that it's much more explicit. And hopefully you gain a better understanding of what's going on. And this is also useful for somebody who may read your code in the future. If they like look at text and then have to create the animations in their head, that code being explicit really can help. So before we can talk about animations, though, we have to talk about layers, CA layers. And the CA and CA layer actually stands for animation, so they're deeply intertwined. And you may know that when you have a graph of UI views or layer-backed NS views, that you also have a graph of CA layers under the hood. What you also need to keep in mind, however, is that there's a second graph of layers being maintained by the framework. Yours is the one on the left, the model layer tree, but there's also the presentation layer tree. And the model layer tree is the one that suddenly disappears when you touch the cable connector. Great. The model layer tree is the one that suddenly reappears when somebody up there presses a button. And it's the one that you lay out. So when you write your layout functions, this is the one you touch. But if you attach, for instance, a fade-out animation to, let's say, a button, if you, during the animation, inspect the opacity value of that button's layer, you will probably not get what you will expect because the animations are only ever affecting the presentation layer tree, which represents what you see on screen. So if you want to go from one layer to the other, you can call presentation layer it's a CI layer instance method, and it will give you the right-hand side for the corresponding layer on the left hand. And you can also call model layer to go the other way around. And why this is important, we'll get to this in a minute. So let's think of a basic animation. Like the most common case is probably going from one thing to another. Let's say and that's commonly done using linear interpolation. So what you would do is you would have, all you need to figure out really is where, okay, you know where you start and you know where you end, but where am I in between, right? So the way to do this with linear interpolation is you find x0, which in this case, let's say we're animating from an x component of 100 to 300, then x0 is 100. Delta x is the difference between start and start and end, sorry. So that'll be 200 pixels, and then t is a fractional value of the duration of the animation we have elapsed so far. So halfway through the animation, we would be at 100 plus 0.5 times 200. That would also be 100. So we'd end up being at 200, which is right in the middle, right? No surprise. That's fairly intuitive. So like no real math here. I'm sorry. So let's say we want to launch this rocket into space. We can do this with co-animation quite easily. First, we create a CA basic animation, and we set its key path. And key path basically tells the framework which property we want to animate. And you'll notice that I'm actually setting position.y, and position returns a CG point struct. At least it did before Swift came out. And CG point being a struct, it doesn't actually you can't call value for key path on that, right? Because like it's not an object. So core animation actually has some convenience methods that allow you to reach into some structs, and they even made up some new properties that aren't even like actual properties in the structs. So I can actually animate only the Y component of the position of the rocket's layer. So that's pretty handy. I need to set the from value and the to value because core animation can interpolate a lot of different values. Those are actually all boxed. So you can pass in numbers and points and translations and colors and whatever. And core animation will take care of interpolating those values depending on whether or not they match the property on the layer that you set in key path. We need to set the duration. I think it actually defaults to 1, but just to be explicit here. And then we add it to the layer of the rocket, and we give it a key so that we can find it later and cancel it if need be. And when we do this, we'll see that the rocket goes all the way up to space and comes crashing down immediately. And why is this? This is because the animation only affects the presentation layer, right? So as soon as the animation completes, it is removed from the rendering tree, and the presentation layer will fall back to the initial value of the model layer, and we never change this. So this is why it comes crashing back down. So the solution for this, which is usually the best approach of handling this, is just after you add the animation, you explicitly set the position to the new value. And then when we try again, we'll see that the rocket actually stays in space, because after the animation completed just now, it would just fall back through the new point that actually doesn't match my example because I didn't fix my code. But bear with me here. Okay, so this is how we animate a single property. What if we were to animate a property with multiple steps in between? Well, we could chain CA basic animations, but that would be silly. Instead, there is a much better way to do this. There's keyframe animations. And keyframe animations are essentially the general case of a basic animation. They have multiple steps, and they can interpolate between all these values. So what you would do is you would create a keyframe animation object, and you set the key path. It's pretty much the same thing. In this case, I chose to animate the contents property, which is a lot of fun if you want to build a GIF framework, for instance. And then I pass in a bunch of UI images for the values property. So then the keyframe animation will iterate through all these images once I've applied it to the rocket. I need to set the calculation mode to discrete so that core animation is not interpolating between the individual frames. Otherwise, we would get like blurry flames on the bottom of the rocket. And once I add this to the rocket's layer, you'll see we have some like exhaust flames down there. So now we have this. We could add both animations separately to the rocket, but that would be kind of a pain in the ass. If matters get more complicated, instead we can group animations. And the way we do this is we create an animation group that's also a subclass of CA animation, so it behaves more or less like an animation. We add the two animations we just created. We set the duration. This is fairly important because animations contained in an animation group are clipped by the duration of the parent group. So if you put a 2-year-long animation inside a 1-second-long animation group, it's not going to do you any good. And then we just add it to the rocket's layer. No magic here, and boom. It's easy as that. So now imagine, like linear rockets, that's fine, but imagine we have a satellite and we want to go around the planet in a circular orbit. Well, we could try and put a whole lot of points into the values array of the CA keyframe animation object, but that would be a whole lot of points we'd have to deal with, and there's actually a better way. Since CA keyframe animation has a property called path that we can use. So first we set the key path to position. We saw that already. And now we create a CG path ref that models the circular path around the planet. For this, we just create a bounding rect, and then we call CG path create with ellipse in rect. We don't need a transformation, and we make that the path of the CA keyframe animation by calling set path, obviously. Once we've done this, we set the duration to 4 because I didn't want the satellite to go so fast, and we set the repeat count to a huge val f, which is just a fancy word for saying infinite. We need to set the calculation mode to paste. This is fairly important for path-based keyframe animations because what it makes the animation do is that it maintains a constant velocity along the path, which is fairly important. Imagine you have, the path generated by CG path create ellipses when rect has 5 points. So there's one point in the top corner, 1 point here, 1 point here, 1 point here, and then another point here. And if we would not set the animation, the calculation mode to paste, the framework would distribute the velocity evenly between all those points. But because 2 points are at the same space, point in space, the satellite would rest there, and that would look pretty weird. So we don't want that. And then we can also set the rotation mode. This allows you to align the x or y axis of the view that you're animating with the tangent of the path. This makes the satellite turn around the center of the planet. And once we add this, we'll get a nice satellite going in orbit. So that's all fine. But if you recall the rocket we saw earlier, the animation wasn't looking very authentic. I mean, first of all, it's my crude drawing skills, but it's also the fact that the rocket reached its maximum velocity immediately as soon as I pressed the button here. And the reason it did that is that we used linear interpolation, whereas stuff in real life actually has mass and inertia, and we need acceleration and deceleration. So if you don't have that, matters will look weird, and I'd advise against ever using linear interpolation, most of the time at least. So what we can do is, instead of creating like a new interpolation function for every kind of animation we want to do, we can add a second function called E for timing or easing function. And we just, and this will map from one point in the animation to another point. So it effectively allows us to speed up or slow down the animation, but not the interpolation, but it gives us the same effect. And we can combine various easing functions with various interpolation functions much more easily. Core animation ships with a couple of easing functions built in. We have ease in, ease out, and default. And of course, there's also linear, but that's not too interesting. Ease in will make the rectangle go faster over the course of the duration. Ease out will make it slow down towards the end of it. Ease in, ease out will make both of them. It will go, like it will speed up and then slow down as it approaches the end. And default, we'll get to that in a minute. So this is what they look like, and you can see they all take the same time, but they have different characteristics. So depending on what you want to do, maybe you want to animate a view in or off screen, or fade them differently. You can play around with these. You can also create one yourself using CA media timing function, and I'll show you how to do this right now. So first, we create a new view. We've all seen this. This is old news, but this is where it gets interesting. By setting the timing function of the animation, we can set that. We can set the easing function, and here we create our own one using 4 control points. By the way, never ever create an API like this, please, with anonymous selector names. Like, what were they smoking? But it compiles, unfortunately enough. And here we set the control points of the cubic Bezier curve that defines the animation. And without going into too much math, cubic Bezier curves are effectively what you see in vector graphic programs, like the things with the handles on them. This is pretty much what we're doing here. And by setting them to negative values and values beyond 1, as I do in this example. This allows us to actually have the rectangle go up before it goes down. So we create a sense of anticipation. And then, yeah, this is just stuff you already know. And when I add this to delay, you'll see that the rectangle will move up, then overshoot a bit, and then come down. Then we'll loop forever. Right. So to recap, never write your own presentation software when speaking at AltConf, because it will severely limit the number of slides you can put into your talk. But if you want to learn more about animation, I would suggest you go to objective-cio/issue-12 in your browser of choice, and yeah, you can read more about this and find out more about animations. And there's all kinds of stuff about pop and frameworks as well. So now how we're doing on time here? 50 minutes. What a coincidence! Because I have an encore. I figured I'd just play some of my greatest hits at the end. So let's talk about Super Mario. You know this guy. This is Super Mario. But just to make sure we're all on the same page, I'll give you a quick recap. Super Mario was created by Shigeru Miyamoto-san in 1981. That's this guy, by the way. He appeared in more than 200 games, and it's the most successful gaming franchise in the history of history itself. So what are the defining elements of Super Mario? First of all, there's all kinds of power-ups. This, for instance, is the yellow Tanuki suit. The white Tanuki suit, sorry. There's Luigi. Actually, last year was the year of Luigi, so we're in like one past Luigi now. There's the princess. That's usually the damsel in distress that you need to rescue. There's a dude called Bowser that usually kidnaps that princess. And there are all kinds of minions that Mario needs to overcome, such as Goombas, Koopas, Lakitos. So yeah, what else is there? There's power-ups. There's coins. First of all, there's plenty of coins. There's power-ups like the magic mushroom, and makes small Mario become Super Mario. There's the Starman that makes Mario invincible for a short period of time. Looks like this, kind of tripping. There's a fire flower that allows him to like shoot fireballs. That's nice. And there's a whole lot more. Like they kind of jumped the shark there, and now they added stuff all over the boomerang flower. What's up with that? And there's also warp pipes. So those are the defining elements. Let's talk about games. The first game that Mario appeared in was Donkey Kong, sorry. He appeared there as Jumpman, and he was rescuing Pauline. So it was like different times back then. But this was a huge arcade hit. So this was only one of 200 games, and I want to take your time for too long. So I figured games won't scale, so let's talk about opinions. What's the hardest Mario game? Well, the hardest Mario game is Super Mario Bros. 2, The Lost Levels. You may say, wait, there is a Super Mario Bros. 2, but The Lost Levels was actually so hard that it was deemed too hard for North American audiences. They instead adapted a different game. Oh, wait, this is what The Lost Levels looks like. And I may have been kicked off the Wi-Fi here. Whatever. Oh, here we go. So it's really hard. You can see that this ever loads. Like this is only the beginning. Oh, Jesus Christ. So you have long jumps, you have death traps and everything. North American audience just couldn't handle it. So you may say, wait, but I played Super Mario 2 and it didn't look anything like that. Well, you actually didn't play Super Mario 2. You played Doki Doki Panic, which was a video game released in Japan to promote a popular radio show on, I think, Radio Nippon. And this is like the cast of the radio show going to Dreamland and fighting the evil Toad Wizard Ward and his henchmen. And what they did, they basically just did the palette swap. So Papa became Mario and Mama became Luigi and so forth. So it was all just smoke and mirrors. So what's the best power-up? The best power-up is not the Tanuki suit. Once you acquire it, you become Fairy Mario, and Fairy Mario can turn into a solid stone statue, of course. A Tanuki is not a raccoon. Don't believe what people say. It's actually a raccoon dog, a species native to Japan, popular in their culture. The best power-up actually is Kuburi's shoe, which you can only find in a single level in Super Mario 3, and it's a giant shoe that you can jump around in, and you can like go onto the plants that would normally kill you instantly. It's great. It's the best power-up. What's the worst power-up? As I told you, they totally jumped the shark with power-ups. And they introduced this thing, the bouncy mushroom, which in French is called champignon boing. And if you play Mario ever, you'll know that it's about precise control. It's pretty much the Vim of, or Emacs or whatever, of jump and runs, right? It's all about precise control, and the bouncy mushroom takes all this away, and it's just super annoying. And it's called champignon boing, which I find funny. Who's the most beloved character? It's Yoshi, of course. Everybody loves Yoshi. Yoshi ranks higher than everybody else in the Mario franchise by popularity. So yeah, everybody loves Yoshi. Which is the best Mario Kart? 64, duh. Which is the worst Mario? That's kind of a tough one. The worst Mario, some say, is Mario Teaches Typing, a game released by Interplay for the computer, actually, for the DOS computer. I never had one as a kid. And you're Mario, and kids type letters, and this will make Mario jump. And there's like, it even tells you which finger to use. I'm not even sure Mario has 5 fingers, to be honest. So yeah, not a good game. But you could argue, well, Rob, that's not even a game to begin with. That's edutainment. So what's the worst Mario game? You know, anybody remember this thing? Exactly. This was a failed, like Panasonic and Nintendo partnered on a CD-ROM attachment to the Super Famicom that was canned. But part of the deal was that Panasonic would get a license to make like first-party Nintendo games. So they released Hotel Mario for their homemade console, the CDI, and Hotel Mario is even worse of a game, really. So, I mean, just look at the. This is like. This gives you nightmares. Like horrible. What? What? I mean, huh? So here we go. First level. And what you do is you play Mario and you close doors. And that's it. And once you've closed all the doors, you've won the level. And then you have the Goombas that open the doors. Sounds great, doesn't it? Okay, but I know what you're saying. Rob, I didn't play this, so what's the worst game anyone actually played, right? Nobody had a CDI, at least I didn't. They didn't even exist in Europe, I think. The worst, and I hate to break this to you, but the worst Mario game that anybody played is Super Mario Land. Like, first of all, this dude, Tatanga, like, who the fuck is Tatanga? I've never heard of this guy. And the princess, Pauline, like, she was given to Luigi, like, they retconned this, and it's now Luigi's girlfriend. She's just a palette swap of Peach anyway. And, like, you don't have the normal power-ups, and it's way too short. 6 Golden Coins is a much better Mario game for the Game Boy, if you ask me. So that's the worst Mario game anybody ever played. What's the best 2D Mario game? So I was going to say Super Mario Land 3, because it's, like, chock full of features, it's non-linear, like, revolutionized NES gaming, but it doesn't have a blue Luigi. And if you don't know, the blue Luigi, Yoshi, sorry. The blue Yoshi, if he swallows any shell, he can fly. Can't beat that, so the best 2D Mario game is Super Mario World, I'm sorry. Best 3D Mario game, Galaxy. No argument there. Let's talk about movies. Let's not talk about movies. Let's talk about voice. This is Charles Martinet. He is the voice of Mario. And he's the greatest guy to meet ever. He's a voice actor, and he's from Brooklyn.
First thing that came to mind, but I started thinking, you know, if it's going to be talking to children all day long, because we're going to be in face mask with things glued to my face, and I would move.
Those were the days.
Mario would move his face. I thought, I'd never seen Mario. I didn't know who he was. I didn't know what I was going in for. More gentle and more, fine together. You go get some sausage. I'm going to get some spaghetti. We're going to put the spaghetti
Okay, so this guy voices everybody in the Mario franchise, like at least the male characters. If you played Skyrim, he also voices the dragon on top of the mountain. That's like a major character in the game. Yeah, let's talk about music. Super Mario is all about music. So there's the beatbox flute version. You probably have seen this. I'm not sure if I'm on the speakers here. And so there, you probably heard this already. But the most important thing that I want to show you before I leave you for good is Automatic Mario, which apparently is not a clickable YouTube link here. So that's that. Thank you.
Okay, so we're going to take a quick break and
Let's not talk about animations. Let's instead talk about state. I do this all the time. If you think of your application, right, as a series of states that it can be in, you know, the user can be logged in, logged out, a text field can be selected, unselected, keyboard can be visible, not visible. That is hard to write and that's hard to maintain, but it's also hard to use, right? If you're a user, you need to find your way through this maze over there. And our responsibility as developers is to guide the user. And one good way to do this is using animations because they provide context. They can reinforce the navigational structure. Think of the UI navigation controller, for instance. When you push a view controller on top of the stack, it like lays over the existing views. And then when you do an interactive pop, you're effectively just reversing this. So animations are much more than just flourish. They're actually very natural, right? I didn't suddenly appear on stage. That would be crazy. I walked. From over there, you all saw that. So you had an expectation that I would arrive here, and I did. So it's just like a very natural thing, right? You go from one place to the other. And one way to do this is core animation. And this is what I'm going to talk about mostly in this talk. I'm not going to talk too much about the UI kit helper methods that are much more high level. They are using core animation under the hood. But one of the benefits of using core animations in the example is that it's much more explicit. And hopefully you gain a better understanding of what's going on. And this is also useful for somebody who may read your code in the future. If they like look at text and then have to create the animations in their head, that code being explicit really can help. So before we can talk about animations, though, we have to talk about layers, CA layers. And the CA and CA layer actually stands for co-animation, so they're deeply intertwined. And you may know that when you have a graph of UI views or layer
Hi, everyone. Good morning. Every morning. It's just silence. Good morning. Excellent. That's much better. I wanted to reiterate one of the purposes of this event is so that nobody gets excluded. Everybody who wants to come and hear from our speakers and hang out with each other can. So if at any point in time you feel unsafe or unwelcome or something weird happens or somebody says something weird, please grab someone in a blue shirt that looks like this. If you can't find someone in a blue shirt, you can find someone at the front desk and they will help you. So our next speaker is a mobile dev from Berlin. He has worked on artsy.io. He's worked on SoundCloud. He's worked on Artsy. He's for hire Robb Böhnke.
All right. Thanks for having me. And let's talk about animations.